Hello, my name is Steffen Riechers. I'm the product manager from Waygate Technology, formerly known as the GE Inspection Technologies. We as Waygate Technologies, we are offering a wide solution of 2D and CT inspection systems covering all kind of applications, from small castings, small electronic samples within the microfocus and nanofocus range, up to big castings and inspection for the range of up to 9 MeV. So this is just an overview for all the products that we're offering. And today, within this webinar, we would like to talk about typical applications that you might address, where you come through and you need to find out whether this is a application for a CT to get the inside view of the sample that you are focusing, or maybe if a 2D application, a 2D scan, just simple acquisition of an X-ray image might be sufficient to see the error or the inclusion, whatever it is, to fulfill process requirements and to follow the workflow within your industry. As an example, we want to address some typical highlights or some typical samples that can be addressed with one of our systems, that is the V2Max S. We're going to that system very soon, but just to highlight these kind of applications, what we're targeting, you might address some typical electronics inspections, such as this small USB stick. This is just an example for a very small chip that is soldered on a small printed circuit board, and you need to know what is the inside of that system or of that sample. It's not a system. So maybe a 2D shot might be sufficient, maybe a high resolution CT is needed. We find out. We will talk about this later on. Another application within the electronic inspection is, of course, a typical printed circuit board, so where we're having multiple components that are soldered on the printed circuit board, and we're having these BGAs, we're having these solder joints connections underneath, we're having tin through holes, so multiple kinds of connections that are mounted on this printed circuit board, and you need to know what is between the layers and what is the connection, how does it look like, are there any cracks, any inclusions, insufficient soldering process. You want to make sure that this is following your process, and you need to know that this is following the workflow that you're targeting as a supplier or as a manufacturer. Another example within the electronic environment is, of course, the battery. Battery is the application globally that is rising constantly, and within the batteries we're having these so-called small pouched cells. These pouched cells are later on included in bigger modules, and these modules are going to be integrated in cars, in trucks, and in mobile devices as well. So this technology is constantly improving, and therefore the technology is working at the limits. So the manufacturing process has to be precise, and you have to know that all the connections, all the solderings, the anode, cathode, the glue inside is at the position where you're looking for, to avoid later complications such as heat development. You don't want to have a battery cell to burn, and that is a typical application for entry-level CT systems with 2D and 3D capability. We're moving a little bit back from the electronics, we're moving more into the metal, and so that is casting. In that case, we have a typical aluminum casting, and from the outside it looks pretty good, so no inclusions or no cracks are visible from that point of view. But do we know the inside of that sample? We don't. So we want to do some 2D scans. We want to do a fast scan with this sample to see whether we have some inclusions inside, and find the solution that is able to address that kind of application. Another very exciting technology, as you know, that is the 3D printing, so-called additive. And in that case, we're having a printed turbine wheel, and that is metal printed. This is kind of small. There are smaller examples outside, and if you can imagine, you can change that turbine wheel to different kind of applications. This is just an example. Printed samples, whether they are printed with metal or whether they are printed with plastic powder. You just don't know what is inside and how does this structure look like. And if you imagine that this will have the application with high power turbo generators, so that is an important topic that needs to be addressed. You don't want to have that sample to break to get destroying your turbo. Another one is a pressure sensor. So that is a piece of metal. It just looks like a piece of metal, but as we know, there's some logic inside, and once this pressure sensor is produced, you need to know what is the inside. And again, these are very safety relevant topics. For the aviation industry, you have to ensure the pressure is at the right level, the same within the production line, different applications, and the pressure sensor is just one example of these kind of electrical manufactured assemblies. And finally, we're having these science applications. So that is a drilling core, and you just want to know what is the inside. Is there any small fossils inside? In that sample, it's a sandstone, but you can substitute, or you can change that sandstone to a different drilling core, and you might not look for small fossils. You might look for inclusions, porosities, the structure of the stone itself, to make sure if the or to find out what is the way how liquid such as oil is able to pass that piece of stone. So that is all about oil and gas research, and that's a very exciting area as well. And then we're having a shell. In that cell, it's a Nautilus shell. So that is, again, in the science environment, you want to know the structure, some research about the inner view of the hidden areas. So you want to know what is the inside view of that shell. Are there any hidden components such as stone, or maybe there's another small shell inside the shell? So that is just science. So all these kind of applications are just an example. On the back side, you see just a quick overview of a 2D shot of a printed circuit board. But now we're coming to the system where we just want to address these kind of applications. But again, this is just an example. We're having different kind of applications that we're able to address with different systems. But our so-called more or less entry-level full D and full CT capable CT system, that is the V2Max-S. And here we have the next generation of the V2Max-S. It's following the well-established design of the V2Max-M that we launched quite a long time ago. And the V2Max-S is our most selling system. We sold more than 500 systems, most selling system in the area of 2D and CT applications. So there's no other system on the market that is able to address that a huge amount of 2D systems, including full CT capability. And what we want to do today is address these applications that we talked about and find out if a 2D application might be sufficient or if a CT application is needed. And then the question is, what is the resolution? Is there a chance to increase the resolution? Do we need nanofocus? Are we able to address this with the microfocus? And yeah, let's find out within the webinar today. Okay, let's have a look inside the V2Max-S system. What you see on the right side is our dual tube configuration. The V2Max comes with the dual tube option that allows you to cover both microfocus and nanofocus application. So we have a 180 kV nanofocus transmission tube, and we have a 240 kV directional microfocus D tube. Both tubes are selectable and can be changed easily by pressing the button. We will see this later on to demonstrate the simple process how to switch between both tubes. These tubes are open tube X-ray tubes, and this technology has unlimited lifetime. So if we move a little bit to the left side, we see the manipulator, and this is not just a CT manipulator where you can see the turntable. All that is mounted on a axis that allows a very flexible application to switch between 2D and CT applications. So you're basically able to tilt a sample once it's mounted on the axis. You're able to tilt and do 2D applications to find the angle that best fits your application to see the errors or the areas that you are looking for. On the left side you see our DXR 250 RT, so that is our high resolution 200 micron detector with a pixel pitch of pixel size of 1000 by 1000, and within this application you're able to address small to mid-size samples. Additional, what we installed here as a option is the increased measurement range, so that gives additional area, and this is widen the application to scan bigger samples in a much bigger diameter of up to 500 millimeters in diameter. So this was just a very quick overview of the current system setup that we are addressing here right now. Maybe there's one thing to mention. Of course, we have a different detector that is available. So that is the exclusive Dynamic 41 with a 200 micron pitch detector that can be integrated into that system as well. So that gives you a broader application for even bigger samples, and depending of your application, what you're looking for, the size of the samples, this might be the solution you're looking for, a 8-inch detector or a 16-inch detector. So that was just a topic that should be addressed, and of course we have multiple other software features that can be selected depending on the application that you're targeting.
So hello, and also a warm welcome from my side. My name is Florian Knigge. I'm an application engineer, also with Waygate Technologies. And I want to do now, after Stefan did the very good introduction on what we are capable of doing, I want to now put it to the test, and I want to use our system here to do a couple of scans. We'll probably not be covering all the topics here in this short webinar due to the time. But what I want to start with is I want to take this demo board here, this example board, and I just want to start and show you a quick and easy setup to do a 2D inspection of this kind of part. So what we will do is we will move to our system just right here. I will mount this part in our system. We will launch our 2D software, and then I will show you just quick and easy how to get within a few seconds a few X-ray images that you can use then for further inspection of your part. So I have now our board here mounted on our sample holder. It's a very easy construction with a magnetic plate and some styrofoam. And we don't really have to care a lot about how we do this fixture and how we orientate the fixture, because in this CT system, as Stefan said before, we have a very versatile manipulator system, so we can move in pretty much every direction. And I will show you this now when I have closed the door. It's our shielding door, so we have to close it even if we're not using X-ray, but we still, when we want to move our axis, we will have the door closed. So now looking from the outside, we can see that our sample is on the manipulator and we can move it in any direction. We can of course move it up and down and left and right, so we can really get what we want to see in our focus. And now, of course, another topic, because it's a full CT capable machine, we have a rotation axis, so we can move the sample, rotate it left and right 360 degrees. And on top of that, which is a very unique feature of this kind of system, is we have a tilt axis, so we can tilt our sample backwards and forwards. So even if we have some portions of the part that are hidden in the standard orientation, we can use this tilt axis to really access each and every angle. And by doing that, we can sometimes even avoid having to do a CT scan after all, because in many cases, a couple of 2D images from different perspectives might be enough, especially for these electronic parts, to really get an idea of whether or not your soldering is correct or whether or not there are other defects in these kind of parts. So it's a very versatile system. We can really make use of all these different axes that we can move, and therefore really get the best out of our image quality. Okay, now we are here in our 2D software, in the quality assurance software, a dedicated software package just for the 2D inspection. And what I want to show you now is just a few examples of how we can leverage this system's capabilities for 2D inspection. So you can see here, this is now an overview of our board that I've just shown you. And now what we want to do is, first of all, we want to magnify a little bit more. We want to zoom in on this BGA, on this ball grid area here. And what we can immediately see is there's something wrong on the top left corner. So something here seems off. So even with this very quick image here, we can see there's a bridge that's not supposed to be here. So this is definitely a defect. Now, if we want to get a little bit more detail on each of these balls individually, so we can of course leverage this the zoom axis a little bit more. We can zoom in even further by keeping this region in center here. So let's just move in a little bit more and just focus on this particular area here. Now if I stop round about here, we still have this top-down view, so I have not used any other axis than the zoom axis. We're not having leveraged the rotation or the tilt axis yet. And you can see here, now there is roughly or very, very mildly, one can see, probably not in the camera image, you can see some defects or some porosities inside these balls. But now if we use our flash filter technology, which is available on all of our systems, now you can see by using a one-click filter, we can really adjust the contrast in a way that these porosities really pop out, and you can now really, of course, first of all see them, and you can of course also evaluate them either manually or automatically, calculating the size of these pores and so on. That's just one of a very easy example on how we can do 2D inspection on electronic components. Another thing that I want to do is, if I move up a little bit more and maybe a little bit out again, we have two other components here on this board. Let me just adjust the contrast once more. So on the right hand side here, we have this SMD part, where we can also see there's something happening here in the middle as well. And on the left hand side, we have these pin through hole components. And now the problem is with this, the pin is now going directionally in the direction of our detector. So it's going from the top to bottom here, and we cannot really judge how full this solder joint here is, this pin through hole connection. So what we can do now is, of course, we can use all our other axes that we have available. We can use our tilt axis, for example, by just tilting it a little bit, and then of course adjusting our magnification again. So combining these two axes, the magnification axis and the tilt axis, we can really, and you can see the more I tilt, the more clearly the image gets. And now you can really see, give me 1 second here, you can really see from these pins going through these components. Now in combination, of course, with the rotation axis as well, we can really find the perfect angle for our analysis, whatever that might be. Again, this is just a very basic example of what we can do with these systems. Tilting a little bit more, rotating a little bit more, we can really bring whatever we want into focus. And the nice thing is, with these tilt axes, we can do that all without opening the door. In a standard CT system, if you want to do a shot like this, you will probably have to 3 or 4 times open the door, take out your sample, adjust it in a certain way, put it back in on the rotation table, and do this a couple of times until you really found your perfect angle that you want to aim for. Here we're just leveraging our axis, and now once again we can take this image into our machine, we can acquire that, save it as a JPEG or whatever we want, and of course we can again use our flash filter technology. The flash filter again is a unique filter that only comes with the Waygate systems. If we use this filter here, now we can really see the whole contrast and all the information that is in this high dynamic detector. So we can see all details, we can see porosities, we can see some cracks as well. So this is again just one of the examples that you can do with these kind of 2D technology. By the way, you can even see here these wires very sharp, and we are still using our microfocus tube. So we are still working with a microfocus tube. So if we want to get even more detail, zoom in even more, get a region of interest which is very, very small, we can just switch our tubes to the nanofocus tube by just one button click, and then work with even higher resolutions here. So that's a quick overview of 2D inspection. Again, there's so much more to talk about. We had a few webinars in the past just covering 2D inspection, but now what we want to do is we want to start with CT, so taking 3D volumes of our parts. So we'll see you back when we start with a CT scan.
So, based on the evaluation we did on the 2D scanning for the printed circuit board, we did a parallel analysis for a pretty simple USB stick, and we wanted to find out whether a 2D image is sufficient to find out some cracks or some errors within that sample. That is not the case, so what we're going to do now is we're going to start a CT scan, and that is why we mounted this USB stick on a very flexible solution to really have a small magnetic plate that can be placed on the rotation table, and that's what we're going to do now. And then we want to see how does this look like within the same system, changing from 2D to a CD scan.
So now that we have mounted our USB stick in our CT system, we are now about to start our CT scan, and I just want to give you a very brief overview of our CT software here on the acquisition computer. So this is our DatasX acquisition. So here we can control basically everything that got to do with the acquisition. So we can control here on the left hand side in this little window everything about the tube. So we can set the current and the voltage of the tube and some other settings. I already did that for this particular part here. On the top here we can select all the settings of our detector, the timing and all other settings, the sensitivity. So this is all done on top here. And then there's some additional settings that we will not all cover in this webinar, of course, but they will all be covered once you have one of these systems in a full training, of course. We have some other modules that Stefan will be talking about later on, so we will cover some of these later on in this webinar. For me, I just want to click the start button now, so that means that this CT scan, this USB stick that you can see here in a 2D slice view, will then be rotating 360 degrees. We will take a bunch of images of this USB stick from all different angles, and once this is completed, we can then use our reconstruction workstation to reconstruct these 2D images into one CT volume that we can then really evaluate in 3D fully with all the details and all the hidden features. So for me, there's nothing left to do other than clicking the CT start button up here, and once this is done, we will wait a few minutes and then we will be back with our CT results and we can have a look at our reconstruction.
As the system is doing its CT scan, I would like to have some words about the new V2Max-S, so the successor of our very successful V2Max-S system with its unique dual tube functionality and the results that we've seen in the application for the electronics. So this was, I guess, pretty straightforward to really see the benefit of having a combination of 2D and rotation axis to really perform both just by clicking the button and switching between the acquisition software of 2D, that is quality assurance, and on the other side it's Datos, what we see right now. Some additional features just to highlight here for the V2Max-S. We of course have our CT functionalities and our software improvements, our constantly steps we're moving forward to bring each and every system to the next level. Just to mention topics such as the helical scan, where we are able to scan in a helical movement from the bottom to the top within the system to really scan large samples, that increasing the height of the detector itself. Another positive effect is this helical movement is reducing the artifacts that are created for horizontal scans due to the constantly rotation and the helical movement. That is another positive effect. Another topic is the offset scan, where we are, of course, can scans that are wider than the mounted detector itself. So this comes in addition to the increased measurement range, what we are able to perform to move the detector from the left to the right. So we will have some information for that as well. The offset scan is giving additional scanning width of the sample as we are moving the sample outside the rotation axis. So that is creating a wider image, or you can scan the same sample size but with higher resolution. So depending on the application, what you're looking for. Another unique software to mention is the multi-BHC. So BHC is for beam hardening correction. That is a new software we recently launched. So that is integrated into the new VTOMax S as well. So this gives you the benefit of reducing artifacts that are mainly created if you're scanning different components, such as, or different materials, I should say, such as plastics with some copper inclusions, for instance, a plug with copper connectors, male and female connectors, and within the CT scan there are some artifacts that are created, and this multi-beam hardening correction filter is really performing as a improvement to really reduce this effect. On the other side, what you see is, of course, it's obvious, it's the larger cabinet compared to the old VTOMax S. We have a bigger door, we have more space within the system, so the way how you're going to integrate a sample, that is much more easier, and of course you can have larger samples to be mounted on the rotation table or on your tilt axis, depending on your application, and you might switch them upside down to scan the area that is in your focus. The tube, I mentioned this in the beginning, we have a high efficient 240 kV D tube with 320 watts. On the other side we have the transmission tube, that is a nanofocus tube, and here we have 180 kV at 20 watt. So that is giving a lot of flux to the sample, and therefore to penetrate and have enough information in terms of photons to get a real good image. Photons, that brings me to another topic that is integrated into the D-tube as well. So that is the high-flux target, where we're creating just more flux, and that is then depending what are you looking for. It can perform in a faster CT scan with the same scanning parameters, or you're just increasing the resolution as you're having much more information. More flux is more photons that are going to penetrate the sample, and this gives you just more resolution, and this is increasing the performance for the CT scan itself. So this is just some key topics to mention here for this very, very versatile system. And now let's see what is the outcome of our CT scan for this USB stick.
Okay, so now we are here at our reconstruction workstation. So we have finished our CT scan of this USB drive. It took a few minutes to scan it. We did a full 360-degree CT scan. Now what we want to do is we want to have a look at the results. So here at our reconstruction workstation, we have all our projection data, our 2D images that we acquired. I can just quickly run through these 1,200 images in this case, depending on what settings you choose for your scan. So here we can see we have a 2D image, 2D X-ray image from each angle. And what we can do now here in this software is, if we go back to 0, we can just adjust the ROI, which region we want to reconstruct. Of course, we don't want to reconstruct the surrounding area to keep our file size as small as possible. We can adjust some additional settings, which I didn't do here. We just keep it very basic here. And then we click the reconstruction start button on the top left side here. So once we click that, the program will ask us to store our project file. I already did that beforehand. It just takes a few seconds up to a few minutes, depending on your detector configuration and your hardware configuration. And once we have reconstructed this volume, we can then load it in one of our volume analysis software. For example, this might be Volume Graphics, or it could be other software products as well. In this case here, we're using Volume Graphics. And what we can see here is now we have our 3D representation of our USB stick. voxel-based representation. I just adjusted the contrast a little bit so that we can see only high-density parts, so everything that is low density, like the plastic of this board inside here is now gone, and what remains is just the high-density metal parts, for example these wires here in the middle, and these components up here on this board. And what we can see from this first image is that we get a very good insight without even opening up the part, so it's non-destructive testing, as the name says. And what we can also see is that these wires, for example, they all look quite okay, but on some of them it is a little bit fuzzy. That means that the resolution of this scan is at its limits to properly judge these kind of defects, so whether or not one of these wires, for example, is broken. So what we can do now is, if we're not satisfied with this resolution here, we can go back to our system. We can do what we call an ROI scan, a region of interest scan. So we just take a small section of our part that we focus on, and for this what we will do is we will use now our nanofocus tube to really get the highest resolution possible, to make sure that we don't miss any defects on this particular part. So to scan our sample now with the transmission tube, with the nanofocus tube, all we have to do is simply switch to the next tube. So we just simply tilt this button here and wait for a few seconds, keep it pushed while the tube is being moved into position. And once the tube has reached its final position, we can just simply condition the tube, warm it up, and then get started right away with the next scan with our transmission tube. So now that we have our transmission tube, our nanofocus tube in place, I took a first image. I started now again with a 2D inspection of our USB stick, of the chip on the USB stick, and as you can see on my screen here, I have now a much higher resolution and a much higher sharpness at this resolution, so now we can really see each and every bond wire. These bond wires are typically around 25 microns in diameter, so very much details here that we can see. And of course now we are still seeing a 2D image, so we see all the structures overlapping in this 2D image, and if we really want to separate all these different layers in this object, we can now take another CT scan of only that region. That's what we call an ROI scan, and region of interest scan. So we will now rotate at this position, giving us a very high resolution scan of this particular region that we're interested in, and then we can really judge each and every individual wire and make sure that there's no problem with each of these wires. So we really can do an overview scan as we did before for the microfocus tube to see the whole part, like this USB stick, and now we can take it up a notch, and we can say we have a high resolution, zoom in just on the region that we're interested in, and we can then do a high resolution scan there as well.
What you see here is a 3D image that was rendered, and the high level of accuracy is seen due to the fact that we're having a nanofocus CT, and you're seeing pretty clearly all the bond wiring that you've seen in the 2D image of the nanofocus already, and now within the CT scan you see all the different layers, and you see the complete chip of that USB stick. In addition to that, you see the complete USB stick. So that was based on a nanofocus CT scan as well, so resulting in a high resolution image. And of course this was a color-coded image within a post-process scan, and the visualization was done in that case with the software volume graphics to see and differentiate between all the different segments on that small electronic device. Here you see the virtual cut of the Nautilus shell that you've seen at the beginning of this webinar. So it's obvious that the inner structure is empty, so there are no inclusions. On the other side there are some samples inside, some spots on the inside of the shell, and from a research perspective that is an interesting point to do further investigations and research on this shell. Here on this aluminum casting you see the porosity analysis, and the red one are really highlighting the critical ones that are big from the size perspective, and that will cause later on a problem. For instance, the drilling hole that are covering some of those red inclusions or red red spots, but on the other side the defect goes into the sample, and this would lead to a major defect. The yellow ones are in the part but does not have a main critical aspect to the whole sample, as where the green ones are completely negligible, either from a size perspective or from the position perspective. The data are overlaid with the cut model, and both data together are matching, and you can see the effect of the inclusions and the effect on the production process here. Okay, so thanks for joining today's webinar about the new V2Max and the application that you are targeting, and we hope you found some ideas on addressing your daily workload in terms of process control, quality, research, so whatever you're doing. So hopefully this webinar was interesting for you, and please keep in mind that this system, the V2Max, is part of our precision line. So we have 3 divisions. We have the precision line, we have the production line, and we have the performance line. So that is the separation between the main segments that we're addressing. So that is high resolution CT, that is the production line, as the name says, for production environment, process control, rapid prototyping, and the other one, the final one, is the performance line. So the main focus here is on the electronic inspection for 2D and for CT applications. So going a little bit more into details to really finalize this precision line, to have the final word about this product line, we have the V2Max S for mid-size applications, and we have the dual tube performance, as we mentioned this, nanofocus tube for really high resolution, small focal spot with the transmission tube. We have the high-flux target capability within the D tube for 240 kV at 320 watts. We have the dual tube option to really switch between both 2D and CT capability, and this was just a high-level overview, as this is content of the webinar. To mention the additional systems within the precision line, we have the high resolution nanoTom M, that is mainly using the application for research, for really high CT scans, where we have a very short focus detector and focus object distance to really have high resolution CT scans within the research environment. Then we're having the V2Max S, as we mentioned this. Afterwards, the next level for more bigger parts and more dense materials, that is the V2Max M, where we have up to 300 kV dual tube capability as well. And if this size is even not sufficient, or we have more dense materials, we are facing the V2Max L systems. So the V2Max L 300 with the dual tube capability, and the V2Max L 450 with a microfocus tube and a mini focus tube up to 400 kV. And last but not least, we have our power scan, where we are able to penetrate even the heaviest samples with a power source, or X-ray source I should say, with up to 9 MeV, and this is really covering the whole branch or the whole segments within the precision line, coming from small high resolution application tasks, as we have seen this within the electronics, for solderings, for electric assembly parts, up to aluminum casting, heavy castings, and then even maximum sample diameters and very dense materials in the range above a meter or even 2 for the power scan. So hope this webinar was good for you, or you got some information to really find out what is your target application, what is your target system, and hopefully you're joining the website, so join the channels we're using, and looking forward to get in contact with you for some application task, whatever it is. Have a nice day. Thanks.